All right, so let's get started on our second set of naming chemical compounds notes. I'm going to go to my present screen from my current slide here. And we are on page number 94 of your unit notes. Let me get my pen ready. I think I'm going to go with purple. And this is page number 94. So in our last set of notes, we did binary compounds, meaning two elements. So now we're going to name what's called ternary compounds, and that's just basically any compound that is not binary is considered a ternary compound. So a compound that's going to contain a polyatomic ion. So we have ternary is going to just be any compound that has 3 or more different elements. And if there's 3 or more different elements, we're going to have something called a polyatomic ion, right? The poly prefix meaning more than one, so a more than one atom ion. And this is table E in your reference tables, are the polyatomic ions. And it has more than 2 elements in its formula. And it also has an electrical charge with it, which makes it an ion. So a polyatomic ion is a group of atoms that behaves as a unit. So it's basically all stuck together, and it's going to have a positive or negative charge, right? That's what makes it an ion. So the polyatomic ion behaves like it's one chunk of an element. So basically it just performs like one thing. So it's not going to separate, and we don't have to balance the charges as all of the elements separately. We're just going to balance it as one unit. So here is our table E. Here are our polyatomic ions. So what you need to be able to do on table E is you need to be able to find the exact formula, and you need to be able to find the exact name as well. I'm just going to try to see if I can make my little pen thing a little bit, my arrow options a little bit more visible here. Okay, so that's table E. And notice they have charges. So now we're going to figure out how are we going to go from the chemical formula to the chemical name. So given a formula, you need to come up with the chemical name. So then the compound contains more than 2 elements. We're going to make sure we're going to use table E in our reference tables. So we need to match the first symbol to its name, and it's going to stay the same. This is very similar to how we named binary compounds. But again, we want to make sure we're using table E in our reference tables along with our periodic table and our periodic table. And we're going to match the second element symbol to its name. If we have a polyatomic ion from table E, we're not going to change its name to ide. If it's an element, we will change its name to ide. So this makes more sense when we do some examples. All right, so our first example is NH4Cl. So the first thing I have to do is I see that I have more than 2 elements. So then this means it's ternary, and I want to make sure that I use table E. I'm going to examine table E, and I'm going to see if anything in my formula matches table E. And I'm going to notice that on table E, that I do have this NH4 on table E. So this is going to be my polyatomic ion from table E. And now I just have an element. So then I have this polyatomic, this NH4 is the ammonium. That's on table E. And now I have chlorine, right, which is the Cl. So when I name this, ammonium, whatever the first thing is, always keeps its name. So that's ammonium. And now since this is an element, I'm going to change the ending to ide. So it's not chlorine, it is chloride. So careful, because this is an element, we need to make sure we change its name. So now I'm going to go and I'm going to see I have more than 2 elements, so I know I need to find something on table E. So what matches something exactly on table E? This OH right here on table E. This is the hydroxide ion from table E, and I have the element strontium over here on the left. The first element always keeps its name. The metal always keeps its name. So I have strontium, and hydroxide. Go back one. And so then that becomes strontium hydroxide. Table E never changes its name. Notice I didn't change anything. I just kept it just as it was written on table E. So now I have Mg and I have this p04. So now I'm going to examine table E and I find this on table E and I have this element over here. So I'm going to find the name using table S in my periodic table. So this is magnesium and this is going to come from table E. And so that's going to be our phosphate. Phosphide is the element phosphorus. Be very careful. So this is magnesium phosphate. Remember, the first element always keeps its name, and then the second, and then table E always keeps its name. So basically, I find this on table E, and I copy down the name, magnesium phosphate. And so next, we're going to do, how do we write the chemical formula? So now, given the name, how do we write the chemical formula? This is very similar to how we did the binary compounds. We're going to match up the name to a symbol, either using our periodic table and table S, and now we're adding table E to the mix. We still have to look up the oxidation numbers or the charges, either from the periodic table oxidation states, or again, table E has the charges of all of those polyatomic ions. So then we're going to crisscross the charges to get an overall neutral charge, just like we did with the binary compounds, because the sum of the oxidation states, the sum of the charges, has to equal 0. All compounds are electrically neutral. If there's more than one polyatomic ion, remember the polyatomic ion basically it functions as a group that is stuck together. So we put it in parentheses to show that it's part of a group. And then we put the subscript on the outside of the parentheses. And now let's work through some examples. So here I have barium chlorate. So now what I need to do is I need to use my periodic table, table S, and table E. So notice this says chlorate, not chloride. So this is telling me this is not the element chlorine. This is telling me that this is coming from table E. This is the polyatomic ion chlorate. And now I have the element barium. So the first thing I do is I go the symbols. So now I have barium and now charges. I have a +2. And where did I get that? +2 from the periodic table. And now I have chlorate. I'm going to find the exact word chlorate on table E. Careful, because there's also a chlorite, so which only differ by one letter. So this is the chlorate from table E. And so I'm just going to write here, this comes from table E. And now I need the charge of this chlorate, which is a -1. That means this whole thing is a -1. So when I crisscross, I need to bring the 2 down, but I'm not going to make that 32 because that would be 32 oxygens. That's not what I need. I need to put this in parentheses because this whole thing is a -1 charge. It functions as a group. So then I'm going to bring the subscript crossed down, right? So then I'm going to have 2 here, and I'm going to bring this and a 1. But remember, chemists don't write the number 1. We don't like it. So then this is going to become barium chlorate. So notice the subscript 2. That means that this -1, 2 of these -1 chlorates balances out the +2. So then this compound is electrically neutral. So now I have ammonium hydroxide. So first of all, I look and I say, okay, first of all, table S does not have anything called ammonium. Table S does not have anything called hydroxide. So then I need to go to my table E. So I'm going to find this word on table E, ammonium. Then I'm going to find this word on table E, hydroxide. And I'm going to copy down their symbols and charges. Symbols, charges, crisscross. That's always how we write formulas. So here's my symbol for the ammonium and the charge, exactly right from table E. The charges are there on table E for you. And now I have the hydroxide, and the charge is -1. A +1 and a -1 cancel each other out, so I don't need to crisscross, but I would need 1 hydroxide, right? 1 of these hydroxide groups, and I would need 1 of these ammonium groups. So then I don't need the parentheses when I write it because I only have 1. You wouldn't be wrong if you left the parentheses in there, but if you only have 1 of a polyatomic, you don't need to include the parenthesis. So now let's look at, I have aluminum sulfite. So now aluminum is the element aluminum. So I'm going to use table S in the periodic table, and I'm going to get the symbol. So that's Al for aluminum. Now I need the second step is my charge, right? Symbols, charges, crisscross. The charge for aluminum is +3. So then this says sulfite. Notice it doesn't say sulfide. If it said sulfide, it would be the element sulfur. This says sulfite, so I need to go to table E, and I need to find the word sulfite. So be very careful because there's sulfite, sulfate, sulfide. All differ only by one letter. So you have to be a very careful reader. So now I'm going to copy the symbols and the charge of sulfite directly from table E. So that's SO3. And this whole thing is a -2 charge. So this whole thing is a -2 charge. So I'm going to put that in parentheses. So now symbols, charges. Now I need to crisscross. So that means I'm going to take this 2 and I'm going to bring it down, and that's my subscript for the aluminum. Now I'm going to take this 3 and that's going to be my subscript for this sulfite. So this is why you need the parentheses, because I don't want 33 oxygens, because that would be invalid, right? So what I have is I have 3 sulfite groups. So when I change this up, and so now let's make sure that I have a balanced charge, right? The positive charge equals the negative charge. I have 2 times +3, that's a +6 charge. I have a 3 times -2, that is a -6 charge. So the sum of my charges, +6 and -6 equals 0. I have a very nice valid chemical compound, and my correct formula, the subscript, right? Because the 2, and then making sure that the subscript is on the outside of the parentheses, because I have 2 of the sulfite groups. It functions as a group, not as a single element. Alrighty, so that is going to end this set of notes. In our next set of notes, we're going to work on elements that have multiple oxidation states. Thank you for joining me.